For question number 8, we're looking for absolute extrema, absolute max and min for the function x over x squared plus 1, and our interval is 0 to 2. And what we know is that the absolute extrema will occur either at a critical value or an endpoint. So let's start by finding our critical values for this function. For critical values, again, we're going to take our derivative and set it equal to 0. And for this, we have to use the quotient rule, so we'll take the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. And what we notice is we're going to end up with 1 minus x squared in the numerator, x squared plus 1 squared in the denominator. And if we're looking for where the derivative is equal to 0, obviously that's going to be where the numerator is equal to 0. So let's look for 1 minus x squared is 0. Obviously x is plus or minus 1. And our denominator will never be equal to 0, so this function is never going to be undefined. So here's where we are at this moment. We have two critical values, and we also have an interval 0 to 2. And the only critical value that lies within that interval is x equal to 1. So what we need to do is see how the values x is equal to 1, x is equal to 2, and x is equal to 3 evolve in this function. So if I plug 0 into the original function, well, that's just going to give me a 0. If I plug 2 into the original function, that's going to give us 2/5. And if we plug our critical value 1 into the original function, that's going to give us 1/2. So if I compare the relative sizes, well, I know 1/2 is greater than 2/5. So this must be our absolute maximum value of the function, 1/2. And the absolute minimum value is just the smallest one there. Absolute min is 0.